Good morning. It's so good to see everyone. It is a minute even before we're ready to start. So I'm just like chatting up here, continue. But welcome to Grand Rounds. I love that there are so many of us in the room. Welcome to March. And thank you for those of you who have joined on Zoom. Often there are a good number of people. So I am excited for this topic. Excited for Dr. Desirae Martinez to be our speaker this morning. Just our brief announcements. The next Grand Rounds is March 20th by Dr. Julia Bellantoni, speaking on transitions of care. We will have Journal Club also this coming Tuesday, March 13th. So ask for the invitation with the articles if you would like it. Please do complete the evaluation that's circulated both online and in person. We appreciate that feedback. And now to the introduction. So Dr. Des Martinez is a first-generation college student born and raised in Denver. Grew up playing competitive basketball, fishing in the Rocky Mountains with her dad, eating her grandma's homemade tamales. Enticed by its unique block plan, she attended Colorado College, where she studied mathematics and feminist and gender studies. Upon graduation, she taught 6th and 9th grade math in Denver, as well as English language classes in La Roja, Wine County. Des is a proud graduate from the University of Colorado School of Medicine and has completed her residency in family medicine at the University of Washington. We were very fortunate to have Des return for fellowship training in geriatric medicine here. We're so glad. It's her dream, it's our dream, sharing and living the dream. Her professional interests include integrative medicine, LGBTQ health, and serving underserved communities. Her personal hobbies include cheering for the Denver Nuggets, reading, skiing, soaking up the sun, and meeting friendly faces. We're very excited about this topic, which really integrates many of her interests: the geriatric gut, the link between the microbiome, human health, and planetary health. So thank you.
Hi, y'all. Thanks for joining me. Please call me Des. To this day, I still wear my security blanket from my School of Medicine days. So thought today was appropriate for it. But thanks for joining me this morning. I know it's super early. I'm not a morning person, so extra thanks to those who aren't either. But today I'd like to talk about gut health, which as an integrative medicine thinker at heart, is truly one of my most favorite topics of all time. And I'm hoping to provide a little bit of perspective on aging through the lens of the microbiome, but also zoom out and draw some parallels between microscopic and macroscopic levels as it relates to human health and planetary health as well. So let's get started. My outline, it got jumbled, but that's okay, is divided into 4 parts. For the first part, I just want to introduce the role of the microbiome, some characteristics of aging and how it impacts human health. In the second part, I'm a context person. I always like to understand things in their context. I'm hoping to provide a couple of examples of how human practices have significantly impacted human health and planetary health. The third part will briefly review some trends of chronic disease and where older adults fit into that. And then the fourth part, I'm hoping to teach a tangible framework to help restore gut dysbiosis for virtually anybody. Okay, let's get started. The first part is about the aging gut, the microbiome, and the virome. So as we age, there are many physiological and pathological changes that occur in the gut. So starting from the top down, in the brain, we have the gut-brain axis, and I'm referring to the bidirectional communication between the central and enteric nervous systems. That's always a dynamic process that occurs throughout our lifetime. In the oropharynx, there's going to be decreased saliva production, and it can lead to increased orthodontal infections. In the esophagus, there are a lot of changes that cause GERD, including not only incompetence of the lower esophageal sphincter, but the development of hiatal hernias, poor motility. In the stomach, you have changes that cause gastritis, including chronic NSAID use that blocks prostaglandin production. You have decreased bicarbonate production, delayed gastric emptying. as well as the increased prevalence of H. pylori, which can lead to achlorhydria, and then of course the malabsorption of important vitamins and minerals like B12, iron, zinc. In the small intestine, you have decreased calcium absorption because the receptors in the endothelial lining just decrease with age, as well as decreased absorption of vitamin D by the skin. In the large intestine, you have a lot of changes that can cause diverticuli, including decreased muscle wall strength, large bowel compliance, and then increased intra-abdominal pressure over time. In the anorectal region, you have changes that can lead to constipation, fecal impaction, and incontinence. And this is largely due to decreased motility, reduced in sphincter pressure at baseline, less compliant rectum, and then also reduced sensation in the rectum itself. In the liver, there are significant changes that cause lower drug metabolism. And that's because the liver overall reduces in size, there's decreased hepatocyte generation, and there's an overall decreased blood flow to the liver on the order of maybe 24 to 47%. And then the pancreas, decreased secretion of enzymes that are important for macronutrient absorption. Now, for older adults, there are some specific social and disease-related factors that we have to take into consideration as well. Older adults socially, it really depends on the amount of human contact that they have, the number of extended family, the number of visitors that they see, the amount of time that they spend alone. Household pets tend to decrease as people age. And then, of course, their living arrangements may differ. They may be at home, they may be in a residential area, and then they spend typically a significant amount of time indoors. Disease-related factors are going to include things like infections, hospitalizations, polypharmacy, comorbidities, and of course, increased antibiotic usage. Now, what do I mean when I'm talking about the microbiome? Well, I'm really referring to very specific microorganisms, and I'm going to talk about them from like an evolutionary timeline and how specific evolutionary mechanisms have allowed for really complex life and multicellular life to really become diverse and adapt and survive throughout time. So let's rewind all the way back to 3.5 billion years ago. That was the advent of the archaea, and they're famous for being the first living organisms to be found and surviving extreme environments, anywhere from like salt flats to hot springs to deep sea vents. And they survived by transferring genetic information locally. And then fast forward about 500 billion years, we have bacteria. They're about 3 billion years old. More than 30,000 species have been identified. And at that point, there was an ability to transfer genetic information long-term through bacteriophages or viruses. And then fungi, 1.5 billion years old, there's more than 5 million distinct species of fungi. And these were really the first multicellular organisms because they are energy-producing experts. And again, similar to bacteria, they are able to transfer their genetic information long-term through spores. Around the same time, you have the protozoa, which is my personal favorite. About 1.5 billion years old, there's more than 50,000 species, and that's really the advent of the mitochondria. They really allowed for the organism to store genetic information long-term, which then allows for complex life. Parasites are a little bit unique in that they're pretty young, 500 million years old, about 300,000 distinct species, and they've really influenced the development of immune systems, specifically in humans. It's type 2 interactions through IgE antibodies. Now, contrast this to the human species, otherwise known as Homo sapiens sapiens, which translates to wise human. I'm not sure why there's a redundancy there, but I didn't name us. We are one species. We're pretty young, like 200 to 300,000 years old, depending on the textbook that you read. And we are comprised of about 70 trillion or 10 to the 12 human cells. And we account for maybe 22,000 genes. Now, for context, a fruit fly has about 13,000 genes and a flea has about 30,000. So we're like somewhere in between there. And then if we think about the human microbiome, there's about 10 to the 13 bacteria in the average person. So that outnumbers human cells by about 10 to 1. There's maybe 500 to 1,000 distinct species in the human body alone. And if you count the mitochondria, which I do because I'm obsessed with them, it's about 10 to the 15. So altogether, you account for about 3 million genes. And this is about 100 to 200 times more than the genes of the human genome. So really, it's like the vast majority of proteins and metabolites in the human body are really either produced by or regulated by bacteria in some way. I found this awesome paper that really looked at the microbiomes between the soil and the human gut. And basically, they found that they are very similar environments that support diverse microbial life. So the similarities are noted on the left. They both are found to just be very dynamic in that they can adapt to their external environmental factors. For soil, that's going to be nutrient availability. In the gut, that's going to be our diet. They both have microbial niches where there's diverse microhabitats of select species depending on their survival needs. So in the soil, that's going to depend on oxygen, level of moisture, nutrients. In the gut, that's going to be oxygen availability and pH gradients. And then each system has their own different zones depending on if oxygen is available. So they have very specific anaerobic zones. In the soil, that's going to be the deep layers. In the gut, that's going to be the colon. And they both share about the same number and type of facultative anaerobes, which are microorganisms that are able to survive in aerobic and anaerobic conditions, signifying their ability to kind of transition between these zones of higher oxygen and lower oxygen. Both environments depend on water. In the soil, it really depends on water for movement and nutrient uptake. In the gut, we really rely on water for mucosal lining. Both microbial systems are involved in nutrient cycling. In the soil, they break down organic matter for plant use. And then in our gut, they ferment dietary fiber for our overall health. They're both pivotal in regulating immune systems. The soil has what's called the rhizosphere. And then, of course, more than 70% of our immune system lives in our gut. And both systems are very sensitive to external stressors. So in the soil, pesticides and fertilizers are going to decrease soil fertility. And in the gut, antibiotics and processed diets and other things or other toxins are going to decrease microbial diversity. So how does the gut change over time? I don't know how this shows up. I'm sure none of you can see the very small print, but that's okay. That's just the bacterial species. But I found a review that really analyzed the gut microbiome alterations from infancy to old age in humans. And what they found was that the composition of the gut microbiome exhibits really specific genus level alterations across the lifespan. So in the early gut, the microbiome is really shaped by the embryonic environment, the delivery method, exposure to different microbes depending on the feeding method, whether it's breastfeeding or formula feeding. For example, those who are born vaginally may have more lactobacillus bacteria, and those who are born by cesarean section may have more like Corynebacteria or Staphylococcus, which resemble the microorganisms of the skin. And really, it's this early life microbiome that's crucial for the development of the brain and the immune system, which of course has an impact on long-term health. Now, during the weaning phase and the introduction of solid food, the gut microbiome transforms from a simple or less diverse system to a more complex or more diverse system that becomes more resilient. During puberty, the microbiota differentiates based on sex factors due to associated hormonal changes. For example, there are specific microorganisms that are associated with higher testosterone levels. And then by adulthood, you reach really a high level of complexity and richness with the development of what's basically going to be your core microbiome. And this allows for increased adaptability and resilience to withstand internal and external stressors. Now, in the elderly, there are several characterizations. Namely, it's the decline in microbial diversity, like kind of similar to the initial stage of life. You have the rise in the abundance of opportunistic pathogens or pathobionts. And then you have emergence of species like bacteroides that are involved in chronic inflammation at the expense of other helpful species like Firmicutes that are basically producers of short-chain fatty acids like butyrate or propionate that are significant for lowering that inflammation. You also have a rise in environmental facultative aerobes like Staphylococcus or Streptococcus, and a decrease in anaerobes like Bacteroidetes and Clostridium, which basically indicates a very severe imbalance at that point. And then in contrast to the microbiota of newborns, there's a lower abundance of Bifidobacterium, which is actually the species that occurs in greatest abundance in centenarians. So those who are age 100 or older have a lot of Bifidobacterium. And overall, this review basically accounted for two trends. The first trend is that a decrease in the diversity of the core microbiome has been associated with an increase in frailty index, not necessarily biological age, as well as hospitalizations, but a higher diversity of the gut microbiome linked with longer lifespan and characteristics of what we consider healthy aging. I found another very cool study, or review. So this review basically analyzed targeted studies of the gut microbiome of older adults, as well as general cohort studies. Now, there are two ways to categorize studies of the gut microbiome versus aging in humans. The first, which is organized on the left, is really studies that investigate changes in the gut microbiome composition over the lifespan or over time. And then the second is studies that really compare alterations in the gut microbiome of older adults who we consider either healthy or unhealthy, which is organized on the right. And they really define unhealthy aging to include things like frailty, reduced physical activity, cardiometabolic disorders, cognitive incline, chronic kidney disease, other chronic conditions. And based on the literature survey of 48 studies, they really identified 3 distinct groups of bacterial taxa that showed consistent patterns of alteration over the lifespan. So group 1 taxa on the left decrease with age, and they were also associated with healthy aging, i.e. we should have more of them. Group 2 consisted of pathobionts or opportunistic pathogens that increased with age and were associated with unhealthy aging, i.e. we should keep these in check. And then group 3 increased with age and were observed to be associated with healthy aging, i.e. we need to nourish these. And so the physiological decline that was found in these studies really are characterized by 2 things. Number 1 is chronic inflammation, and then number 2 is loss of the mucosal barrier, otherwise known as leaky gut. And these 2 processes are heavily mediated by the microbiome. So this is a graphic summary. Yeah, pretty tiny. This is a graphic summary of some of the key metabolites produced by the 3 bacterial taxa groups. And the effect of each of these has on either negatively or positively regulating various disease processes like chronic inflammation, cellular senescence, insulin resistance, cognitive decline, et cetera. Now, I've highlighted an example on the right because I can't even read the small, tiny print. And I write that small. Oops. So group 1 taxa, again, bacteria that increase with age and are associated with healthy aging, produce the short chain fatty acid butyrate, and that is involved in histone deacetylase regulation. And if you go back to, I don't remember when we learned about DNA transcription, but that is the enzyme that removes acetyl groups from histones and is involved in DNA transcription, which of course influences cell expression, or DNA expression, or gene expression, cell cycle progression, and apoptosis, which inhibit processes involved in cellular senescence and DNA damage. So this is an example of how these microorganisms directly influence the metabolites, which then play a role in regulating disease processes. Now here's a table of some of the metabolites that are produced by these microorganisms and that are associated with aging, either advantageously or in a harmful way. I'm not going to go through every single one because I don't think I have the time. But I've already mentioned short chain fatty acids like butyrate or propionate. These are incredibly anti-inflammatory. They're involved in really regulating homeostasis. They're anti-cancerous and pathogenic. Phenolic derivatives, they protect against oxidative stress and again are anti-inflammatory and anti-cancerous. Now the phenol derivatives are interesting because, what do I mean by leaky gut, or how does that actually happen? Well, there's a protein called zonulin that basically breaks down the tight junction proteins in the endothelial lining, and at low levels, the tight junctions can remain intact. Now, phenol derivatives keep those levels of zonulin pretty low and help protect the gut lining through those tight junction proteins. Now, lipopolysaccharides are notorious for being incredibly pro-inflammatory. They are involved in basically every metabolic disease process that you can think of. There are certain species that produce it, and then other species that increase the absorption of it. Okay, I can't really talk about the microbiome without at least mentioning the virome. So namely, it's very distinct in that it's non-living. It's considered to be the greatest abundance of genetic information on the planet. And for humans, over 50% of our genes were inserted by viruses. 8% of those were by RNA retroviruses. And it's ubiquitous. So viruses occur on the order of magnitude of 10 to the 30 to 10 to the 31 of each of our air, soil, and water systems. In the human body alone, there's about 10 to the 15 viruses. And then there's 10 to the 8 viruses per gram of stool by the first week of life. So they're everywhere. And of course, the interaction between viruses and the microbiome and the human host occur at the ribosomal level, which is a very tightly regulated process that depends on very specific concentrations of metabolites and proteins. The virome has really been, again, integral in our role of evolution. This paper, I think, was published in, I want to say earlier, like 2008, but it found in mouse models that the retrovirus ARI-15 was responsible for encoding the gene that destroy the mitochondria in sperm to ensure that only the maternal mitochondrial DNA was inherited. So this helped postulate that maybe that's the process that occurs in humans. Okay, the second part. Again, I like context. So I'd like to highlight a couple of practices from humans that have really impacted human health and planetary health overall. This is a picture of Lake Urmia in Iran. It was one of the largest saltwater lakes in the entire world. The picture on the left was taken, I think, in the 1990s, and then on the right, it was about 20 teens. And over that period of about 20 years, over 95% of it has dried up. Okay, so if I were to think of a narrative that has really kind of set the tone for modern day practice, not only in medicine, but also in agriculture, which is the second example I'll talk about, it's really germ theory. And as a refresher, I think we're all familiar with germ theory. We experience it every single day. We can't avoid it in our culture because that's just how I think Western medicine has been developed. But it was developed by the scientist Louis Pasteur in the 1800s. And his theory was basically saying that, pathogens invade the body and cause disease. And the approach thereafter focused on sterilization, vaccination, antibiotic usage to really eradicate the external pathogens. We're all familiar with that. But then in contrast, around the same time, there's another scientist called Antoine Béchamp. How many of you have heard of the train theory, by the way? Oh my goodness, it's so fun. Okay, cool. So this theory gets me really excited. So this theory basically says, actually, a healthy body prevents illness even with pathogen exposure. And the approach really is focusing on holistic wellness and immunity of the host. And the focus really is in, how can we optimize the body's internal environment? Now, I think about humans and how kind of egocentric we can be in many ways. And I think that narrative has just kind of dominated since the beginning of humankind, really. So much to the point where when you look at the definition of nature as it stands today, this is it. So nature is a noun. The phenomena of the physical world collectively, including plants, animals, the landscape, and other features and products of the earth, as opposed to humans or human creations. So we've literally written ourselves out of the nature narrative. And there's always been let's conquer nature. We got to withstand Mother Nature. There's some feminist dynamics that I won't go into. That's a different talk. But I like to think of nature really as the micro and macro ecosystems of all living things. Humans just being a subset of that, and the youngest subset of that, if you think about it. So one of the first examples of kind of human practices that has really impacted health is really the advent of the antibiotic. So penicillin was discovered in 1945, and then for 30 years thereafter, there's the golden age of just antibiotic discovery. So the CDC, I think the most recent trend that I could find was from 2022, and there were some key statistics about US antibiotic prescription rates at that time. So in that year alone, there were about 236 million antibiotic prescriptions. That accounts for about 7 prescriptions for every 10 people, so about 70%. 80 to 90% of those were outpatient, and 20% of those at least were deemed unnecessary. Now what's the impact long term? Well, you're going to have increased sterilization that leads to weakened immune systems and increased vulnerability. it's gonna perpetuate the need for more antibiotics. There's more antibiotic resistance over time. And then there's paper after paper that's been linking increased antibiotic rates to increased incidence rates of cancer as well. Now, this is a map of the antibiotic prescription rates in the United States in the year 2023. The darkest blue has the greatest rate. So per 1,000 population, those dark blue regions, the range is about 887 to 1,249. And that's more than one antibiotic per person in those regions for that year. And the trends have only been increasing since about 2020. I wonder what happened from 2019 to 2020. I'm not quite sure. But the trend, we're approaching like 800 per 1,000 people in any given year. And then for funsies, I compared maps of antibiotic prescription rates and cancer mortality rates in the United States. On the left, you have prescription rates in the year 2021 by state. And on the right, you have age-adjusted cancer mortality rates by state as well. And, that's pretty similar to me. There was a paper, I think it was published in, it says right here, 2018, that looked at the antibiotic prescription trends in older adults from the years 2011 to 2014. And they found that US adults age 65 or older at that time received enough outpatient antibiotics for every older adult, for every single older adult at that time. And the most prescribed were, you're gonna love this, quinolones, which we love, and azithromycin. And of course, those trends have only continued to increase since then. Okay, the second example that I can go on and on about examples, but I know I have limited time. But the second example is really the industrialization of agriculture in the path towards efficiency. Now, when I was talking about the Homo sapiens species, we're relatively young, about 100 or 200 to 300,000 years old. But really, the shift has occurred in such a short amount of time, like within the last 100 years. Now, if you take a percentage of that, I think that's like 0.0005 or something like that of amount of time that we're seeing this significant change. So in the early 1900s, it was characterized by diverse farms. Most of Americans lived in rural areas. Throughout the 20th century, you saw a rapid transformation that preceded the previous 13,000 years. And some of the key changes were, specialization. Monocultures have replaced diverse farms. Livestock has been separated from crops, and there's been selective breeding for a selective outcome. So, chickens, for example, we have them for meat and for eggs. Then there's been advancement in mechanization that have really reduced labor costs, but also labor workforce by more than 90%. And then it doubled the output from 1950 to 2000 alone. There's been an influx in chemicals, so there's now a heavy reliance on fertilizers and pesticides and antibiotics. And then, of course, the first genetically modified organism was introduced in 1996, which was the soybean. There's been a significant consolidation because there's significant economic advantage of scaling your operations. And these have largely been led by government initiatives to make sure that there's enough distribution and supply for the growing population. And then there's been significant market concentration where a few corporations or businesses really hold the power over our food systems. And then there's something called vertical integration, which is basically where one corporation controls all of the the processing, the producing, the distributing, and sale of that one product. Now, the impact has been pretty significant. So in the environment, you have degradation of the soil and water contamination. And then for public health risks, you have, of course, increased antibiotic resistance and then more exposure to toxic chemicals. Now, one of these chemicals is Roundup. I'm sure who's heard of Roundup or glyphosate? Nice. It's hard to avoid, truly. This is a map, and this is a grid from 2015 about the application rate. And again, the application rate has only increased since then. But this was the prettiest map that I could find that kind of zoned in on certain regions. But for some historical context, so glyphosate or Roundup was, patented by Monsanto in 1970, and then it was marketed as Roundup to the general public in 1974. Fast forward to the mid-1990s, that's when they developed their first genetically modified organism, which was the soybean, to literally withstand the toxic exposure of glyphosate because they found that it killed everything in sight. And then, from like mid 1990s to like early 2010s, there's been cancer cases. The first famous one was the non-Hodgkin's lymphoma case that they lost in a big trial. And since then, since 2018, Bayer bought out Monsanto. They've settled for more than 100,000 lawsuits, I think, and about $10 billion. And why do I mention this? Because the impact has been pretty significant on the like cycle of life, which is the carbon cycle. There's been a huge dysregulation. Let's go back even farther to like biology. So carbon, of course, is the sixth element in the periodic table. It's awesome. It can form four strong covalent bonds with itself, with other molecules like oxygen, sulfur, and nitrogen, hydrogen. And it's really important in regulating our planet's temperature as well. The carbon cycle really is just the continuous process where carbon moves between the atmosphere, the living organisms, the sea, the land. And so, plants absorb carbon dioxide through a process called photosynthesis, where they make carbohydrates. We eat those carbohydrates as animals and integrate it into our bodies. We then die and decompose, which then that carbon dioxide gets recycled into the atmosphere from the soil, and rinse and repeat. And the imbalance is that the rate of carbon dioxide production really is exceeding the amount of carbon that's restored in the soil. So here are two graphs representing the carbon dioxide emissions worldwide. So on the left is the world from 1750 to 2023. And you can see the growth is exponential. It's not really slowing down anytime soon. And then on the right, it's the cumulative carbon dioxide emissions organized by country. The United States has always led. And then the second impact is, again, talking about our soil systems. So this map shows the distribution of carbon across the top 30 centimeters of cropland soil worldwide. Now, the higher concentrations are in the brighter colors like purple, green, and then the lower concentrations are in the light yellow or gold. And you can see there's a global depletion of carbon worldwide. Now, depending on how the soil is managed, the soil can either thin or grow. And if we know the rate at which it is thinning, then we can kind of predict the number of years or harvests that are remaining for that region. Now, some regions are degrading at a rate of about 0.5 centimeters annually. And so some scientists that maybe have a little like doomsday perspective are predicting that if the rate in some regions are degrading at a rate of 0.5% centimeters per year, then you have about 60 harvests left for that region to sustain food source for those. And then the other impact that we're seeing is just a significant increase in the chronic burden or chronic disease burden. This shows a graph in the United States from 1990 to 2021, and cardiovascular diseases and cancers have always led, but all of the trends are increasing. Again, that little red spike is respiratory infections and tuberculosis. That was around 2020, if you all remember that. Yeah, so I wanted to mention kind of this historical context because really, I think what we're seeing is in this collapse of human health, I think it's really just a manifestation of the collapse of planetary health. And I don't think that we can talk about one without the other. Now, some of the trends that we see these days are, again, significant disease burden. So this is organized by age, again, from 1990 to 2021. And the unit of measurement on the left is something called a disability adjusted life year, or a daily. And one daily is equal to 1 year of life lost, either due to premature death or a year lived with a disability or a chronic condition that's impacted somebody's function. And it's not surprising that older adults are kind of leading the trend in the rate, but the rate is significantly increasing compared to the other age groups. Similar with cancer mortality worldwide. So on the left, this shows the rate of change of cancer mortality from 1990 to 2019, and we're now exceeding, I think, 70%. On the right side, you have deaths from cancer by age worldwide. Again, older adults are leading the pack, and that trend is, for all age groups, really isn't downtrending anytime soon. It's not really surprising. But the cancer incidence rate by age group, older adults really are exceeding other age groups significantly. So There's about 1.5 thousand new cancer cases per 100,000 people in any given year from 1990 to 2021. Now, I thought this graph was really interesting. So this is who Americans spend their time with, organized by age. So, organized by who they spend their time with. So as we age, we spend a significantly more time alone. And that starts around like age 40. And when I take a step back and I think about, again, like microscopic and macroscopic parallels, I think about cancer, like the process of cancer. And the average cancer cell has about 20,000 genetic injuries to it. And if a cell is living in an integrated environment that really has a cohesive network of communication between human and non-human cells, like that should never happen. And it's only in a sterilized environment that a cell really reverts back to vestigial forms of glucose metabolism that allows for cell proliferation to go unchecked. And I think humans are kind of similar. Not that we proliferate unchecked, but when we're taken away out of our community and our network, then we become a devolving system, and we see that in our older adults all the time. So I really think it's about community. Going through all of these graphics, I found myself to be really curious about fertility rates, because I think the first sign of a population that's going to go extinct is really downtrending fertility rates, among other things like chronic disease burden, differences in sex, a wider distribution between younger and older individuals, and then yes, so many more. So on the left side, this is the total fertility rate projections through 2100, which is weird to say, if they continued at the current rate. And this is kind of approaching the borderline of what's called the replacement fertility rate. And that is the total fertility rate required for that population to exactly replace itself from one generation to the next. And already there are countries like, I want to say South Korea, Japan, that have reached the fertility rates of like 1.5. And then on the right, there was a study that kind of organized the world into 8 different regions based on fertility rates, so ranging from very low to very high. And they found that all regions, except for one that showed a slight increase, but the majority of them significantly had lower fertility rates over about 20 years from 2000 to 2021. And that was a study that was published in 2024, so very recent. Now, again, we talked about from a biological perspective of like, what are the signs that a population is going extinct? But from a clinical perspective, or at least we're being taught, at least in this stage of my career, to kind of recognize signs of end of life and facilitate conversations about values and goals of care. But to me, again, on a macroscopic level, I wonder like how to recognize those same signs for humanity. And I wonder how those conversations might go on a global scale to maybe ignite some change. Okay, back to something tangible. All right. Okay, good. Okay, so let's see. I wanted to, kind of provide some context on the microbiome and kind of some factors that have really impacted health on a human scale, but also on a planetary scale. But I also wanted to kind of introduce a framework to help restore the gut microbiome that can be applied to virtually anybody. And I borrowed it from the Institute of Functional Medicine. How many have heard of that? Nice, cool, okay. Let's see, so like a brief background. So it's an accredited institute that really, the philosophy is really aiming to identify and address the root cause of disease through like a very systems approach, and then create like a holistic patient-centered treatment plan thereafter that can restore balance. It really relies heavily on the terrain theory of disease. It was developed by the biochemist Dr. Jeffrey Bland. He's considered the father of functional medicine in 1991. And then the institute itself has been accredited since 2001. And you can, like anybody in here could get their Institute of Functional Medicine accreditation. I think there's like one foundations course and then 6 core courses. I've taken 2 of them through residency because that's when you got a major discount, but no longer. So it's called the 5R Gut Restoration Protocol. Number one, remove, replace, reinoculate, repair, and rebalance. So we'll go through each of these now. Now, going back to that one paper that showed the very distinct three groups of taxa, they actually looked at the interventions and how that impacted not only the microorganisms, but the different metabolite concentrations and how that's down-regulated processes of chronic disease. The interventions included things like prebiotics, probiotics, phenol derivatives, Mediterranean diet, and increased fiber intake as well. Okay, so the first step is really, let's remove the harmful triggers and pathogens. Really, the purpose is to eliminate stressors that affect microbial balance, inflammation, infections, and toxic accumulations. For pathogens, of course, we're going to be thinking about H. pylori and C. diff, but also Candida and other viruses. Now, food sensitivities, there's like an entire list. I'm not saying go crazy and say eliminate everything, because then what would you eat? But those would include gluten, dairy, processed sugars, processed oils, artificial sweeteners, soy, alcohol, and of course, other processed foods. Toxins not only include like pesticides and heavy metals, but prescriptions like PPIs and NSAIDs. And of course, you always have to be mindful of chronic stress due to that gut-brain axis. So the first strategy is really kind of more of an elimination diet approach. I hate the word diet because it sounds like it's a trend and you kind of only do it for a short term. But the Whole30 program, I don't know if anybody's heard of that in here, but it's an accessible program that outlines a really nice way to think about elimination diet. And now that to me is a little bit aggressive because they tell you to eliminate things like legumes and grains for that time. But basically, you eliminate the trigger for about 4 to 6 weeks, and then you systematically introduce them one by one to see how somebody feels, whether it's impacting your mood or energy or sleep. And then really you, of course, want to continue thinking about appropriate antimicrobials, whether it's a fungal, parasitic, or bacterial infection. And then along this process, an easy way to support liver detoxification is to increase the intake of cruciferous vegetables, like broccoli and Brussels sprouts. And then we can't ignore stress management, which I won't go into deeply here. Now, the second step is really to restore proper digestive function to optimize nutrient absorption. And there are a few therapeutic strategies that these practitioners use. So the first one is actually supplementing with betaine hydrochloric acid with pepsin. And this is going to help with those important vitamins and minerals that we just have a hard time absorbing. So B12, iron, zinc. And of course, this is contraindicated in certain conditions like peptic ulcer disease, esophagitis. And you have to be mindful of like concurrent NSAID use as well. And then you can supplement with broad spectrum enzymes to help macronutrient absorption. And there's also specific enzyme-rich foods that you can easily get, like pineapple and papaya. Bitter herbs are going to help with fat metabolism, and then choline-rich foods like eggs and organ meats are going to help enhance bile production. Now, the third step is to repopulate the gut or reinoculate it with healthy bacteria. This is, of course, going to support digestion, immune function, and mental health. Now, the first therapeutic strategy is probiotic supplementation. And really, you want to use multi-strain probiotics containing lactobacilli, bifidobacterium, and Saccharomyces boulardii. And interestingly, the lactobacilli and the bifidobacterium are the colonizers, and the Saccharomyces boulardii don't colonize, but they actually support the longevity of the probiotics, of the healthy probiotics in the gut. You want to aim for about 25 billion CFUs. And to give you context, like a serving of yogurt has about 1. And then for those who just completed a course of antibiotic use, you may want to consider higher dose or higher potency probiotics, like 50 plus billion. You can introduce prebiotic fibers like resistant starches in the form of legumes, vegetables, fruits, whole grains, and then of course soluble fiber rich foods like flax seeds, chia seeds, garlic, to name a few. I could go on and on about the nutrition aspect, but I won't. Fermented foods are going to introduce live probiotics. These can include things like sauerkraut, kimchi, kefir, miso, tempeh yogurt, kombucha. You have to be careful about kombucha though, because it can have a lot of added sugars. And then again, those polyphenol derivative groups like berries, green tea, dark chocolate has to be above 70%. And even red wine can help feed beneficial bacteria. And again, really maintain the integrity of the gut lining by lowering those zonulin. And then repair, you want to heal and seal the gut lining. This is again to reduce inflammation and to restore the leaky gut. And of course, the leaky gut is associated with things like allergies and autoimmunity. When I take a step back and I think about autoimmunity, it's really an identity crisis. Like the body is unable to recognize foreign from itself. And again, I think if we zoom out, I think humans might be having a little bit of an identity crisis, at least the United States is right now. There are specific amino acids that are pivotal for maintaining the integrity of the gut lining, one of them being L-glutamine. And you want to have the total daily dose be about 15 grams or 5 grams per day, or sorry, 5 grams TID. And then collagen and bone broth are going to be very rich in glycine and proline, which are, again, really helpful for restoring the gut lining. And then there's a slew of anti-inflammatory nutrients like zinc, vitamin D, curcumin, and omega-3 fatty acids. For omega-3 fatty acids, you can find them in fish oil or flax seeds, of course. But you really want to aim for a minimum dose of about 2 grams daily. And then you want to look for the ratio of EPA to DHA to be 3 to 2, because that's the naturally occurring ratio that is found in, say, fatty fish. And then there are certain soothing herbal remedies that help coat and protect the gut lining, like aloe vera juice and slippery elm. And slippery elm can be really helpful for those with like sore throats during like an acute cold. And then finally, like rebalance, like how can we also focus on some of the other pillars of health to help maintain healthy gut health? So that's going to be stress reduction, aiming for quality sleep, engaging in some sort of physical activity, and engaging in more mindful practices, especially around eating, whether it's increasing your socialization with meals or being mindful and really taking time to chew your foods, because that can increase the release of digestive enzymes. If that framework is like a little too stepwise, a little too much, there's an even simpler one. And this is the 30 plant weekly challenge. So I don't know who's heard of this. Nice. Okay, cool. So this was from the American Gut Study. And this was one of the largest open source crowdfunded studies like of all time about the microbiome. It analyzed data from over 10,000 participants across diverse geographic, dietary, and lifestyle groups. And it really provided groundbreaking evidence that diet alone, particularly the diversity of plants that you eat, of about 30 plus per week, strongly correlates with a healthy gut. And so my challenge to all of you today is to really be mindful of the number of plants, distinct plants that you're eating, because people can have their same 5 or 6 rotating vegetables, but at the same time, diversity is the name of the game. And so there are plenty of ways to add that in, including like herbs and spices, and that would totally count towards your weekly total. So that's another simple concept that you can introduce to really, have somebody think about, okay, what is my diversity around the plant world? And then I just wanted to mention something about supplements, because I think I get this question a lot. The truth of the matter is that quality really, really matters, just because of the lack of regulatory processes in our country. And so I, typically tell people that, health food stores are in the business of providing higher quality supplements. Granted, they're more costly, but swansonvitamins.com is an awesome website, and it offers very discounted high quality supplements. Who's heard of FullScript? Oh, just one. Wow. Okay. It's awesome. You all should have an account because it's free and you can get supplements wholesale. But it's a prescription platform for practitioners. And then if you invite patients, you can, give them discounts as well. But it's cool because they independently test supplements across their catalog for the quality. Trusted brands that I find to be more affordable are Thorne, Life Extension, and Now Foods. Now Foods you can find in a lot of health food stores. That's like the orange and white bottle. And then other brands are listed there. And then who's heard of NapMed Pro? Oh my gosh, it's so fun. You're gonna have like a heyday on like one of your days off, I know it. So it's a database for like herbs and supplements and foods. And really, it's all research-based. So if you wanted to find, for example, like the effect of cinnamon on lowering blood sugar levels, you type in cinnamon, it gives you all of the evidence for it, and it organizes it for like most impactful, kind of equivocal, and like maybe harmful. And it's cool because it gives you very specific clinical guidelines for like dosing and for how long and what to expect. And then throughout, so this is clearly like a topic that I care very deeply about. And over the last, I don't know, like 7.5 years, I've read, lots of books, seen movies, podcasts, like watched educational series. And here's a list of some of my favorites. I won't go through all of them, but, earlier I kind of, when I was talking about like the extinction of like humans and, one of the most like uplifting, positive, like most hope-inspiring movies that I've ever seen is The Biggest Little Farm. Who's seen that? Oh my gosh. Okay, it's free. I think you can watch it like on Hulu, I think. But it's awesome. It's about this couple. He's like a wildlife cinematographer and she is a chef. And they lived in an apartment in LA, but they had a very noisy barking dog. When they were evicted from their apartment. And, they said kind of, let's, whatever, we'll start over. They got a loan from the bank and they bought like this really grungy farm about like an hour north of LA. And it shows how they transformed it into this wonderful, bright ecosystem over 7 years. And it's like, it uses techniques of regenerative farming and introducing soil or carbon back into the soil. And it's just so inspiring. So I definitely recommend watching that. Okay, I think that is really the end of it. So here are some of my references, a lot of them actually. But thank you. I appreciate your time today.
Wonderful talk. Thanks for covering so much ground, soil, gut, all things. Wendy.
Des, thanks for providing such an interesting perspective on the gut microbiome and its interactions with our ecosystem. I don't know if you're familiar with MotorPack, a large national common fund, NIH common fund study to try to advance our understanding of the molecular mechanisms for the health benefits of exercise. And you didn't touch on exercise very much, but when we were designing MotorPack, we actually wanted to study the gut microbiome.
No way.
But we got briefed on it, and we would have had to control diet for several days before an exercise exposure to isolate the effects of exercise on the gut, because the level of plasticity of the microbiome, the gut microbiome, is very high.
It's dynamic,
it changes dramatically every time you eat.
Yes.
My understanding, anyway.
Yeah.
So given that, how do we rigorously study the mechanistic role of the gut microbiome on, say, cancer mortality or just prevalence of colon cancer or obesity, which it has been linked to, if we don't really have a way to study it in real time?
Man, that's the question that I'm also wondering. Yeah, I think my like cynical perspective is really dependent on funding. And the truth of the matter is that, like food and healthy diets and even supplements, like they don't really make a lot of money. And in a world that's kind of dominated by incentivizing like prescriptions and treating volume and numbers. I think there's a giant hurdle to like secure funding in that way. But specifically if you're wanting to isolate, how diet affects, the microbiome in studies, I don't know how to answer that question eloquently, because you're right, it changes so dynamically. But I think that's one of the best things that you can impact your diet within 24 hours, or you can impact the health of your microbiome within 24 hours. We know that after somebody takes an antibiotic. Yeah, I don't know the answer to your question. I'm sorry. I actually didn't. I focus more on like nutrition and diet factors versus physical activity. Yeah. That'll be the next talk. Just kidding. Don't sign me up again. Yes, Wendy. Tell me more.
I certainly echo Wendy's point. Thank you so much for a comprehensive talk and your enlightening and entertaining perspective on this such a complex topic. I noticed toward the end, you really focused on how to restore the gut microbiome with nutritional strategies. And I was thinking about nutritional strategies perhaps from a different perspective. As we know, if you broadly try to educate people on how to eat well, they do not adhere to it all that well. So there's major barriers to adopting healthy dietary patterns. So now going back to the beginning of your talk, you said, major important aspects of the gut microbiome is to produce things like short chain fatty acids.
Yeah.
So might it be a prudent consideration to advance the supplementation of short chain fatty acids, appreciating that maybe older adults do not consume adequate dietary fiber and other compounds that would produce short chain fatty acids? So might that be another nutritional strategy that older adults could adopt to try to promote
Yeah.
gut health?
Yeah, like more targeted supplementation. And I think that's actually the emphasis on the framework of the Institute of Functional Medicine. But to me, it kind of, like, because they'll go down to the weeds of the cellular processes that are involved and literally tell you, okay, now you need to supplement this and this and this, to the point where, in my opinion, they're kind of replacing your prescriptions with like supplements. And so at the end of the day, you have like 10 supplements that you need to take. Now, supplements are pretty costly, but also there's been, plenty of studies to show that, you don't quite get the synergistic effect from supplements that you would get from like a natural food source. So of course, I'm always advocating to eat food sources that are closest to like the light and carbohydrates produced by plants. But at the same time, I do think that, supplementation with like butyrate or propionate, for example, could be significantly beneficial. But I actually didn't look at studies that, to even articulate further on that. But I definitely think that there's room to kind of target specific areas like short chain fatty acids. I'm sure there's data out there, but I haven't looked into it.
So you said that one yogurt is like 1 billion probiotic.
Yeah.
And then you
few.
recommended 25 billion. And so
25
I'm not-
servings of yogurt.
I'm not planning any, I would be in the bathroom all day. So I was just wondering what I just talked to a patient yesterday, was like, I'm giving you antibiotics, take some probiotics. And I left it at that. And I they're going to go to the grocery store and have an adventure of
Yeah.
what they're going to do. So
That's
for
part of the fun,
you,
too.
With your expertise, what do you say? Go to Whole Foods and find something with what do you say to get that 25 billion in need?
Well, first of all, you don't have to do it indefinitely because, again, because the gut microbiome is so diverse that if you supplement with, probiotics for for a long period of time, you can actually create more of like a monoculture environment. And so it's never like perpetually, you never really want to advise that to somebody to take indefinitely. So, typically it's like take something from the fridge because it's going to be higher likelihood that those probiotics are still living. And like you don't have to go crazy on the cost, maybe like 4 to 6 weeks worth of dosing to, especially after antibiotics. So something from the fridge and like that'll get you through about 4 to 6 weeks. Yeah, but specifically looking for those strains of lactobacillus and bifidobacterium. And then if you can, find the Saccharomyces boulardii as well. But yeah.
Thank you. I was going over your therapeutic approaches in the supplementation, and I noticed that you didn't talk about fecal matter transplant. And I'm curious
It's so
if
cool.
what your thoughts are on that approach and kind of what the cutting edge nowadays, where the research is going and how that's coming out. Is that an effective approach? And then to Wendy, with your exercise, what if we exercise patients and then collected their fecal matter and then transplant it to a sedentary group, and then we can look at what changes between to target the exercise induced?
I think we should do that in animals.
That would be cool. In animals, right?
Perfect.
No, go straight to humans.
I think Zach and I can do that.
No, I love it. We have exercise, we have fecal matter transplants, and then we have like targeted supplement. I think we have a protocol to restoring everybody's gut. No, truthfully, like I know like the bigger picture of fecal transplants, but I think again, if it kind of like takes it out of like you take the organism out of the context by just focusing on replacing somebody's fecal matter. And I think if you don't talk about lifestyle habits to some degree, you could, end up with like similar conditions that led to that disease pathway in the first place. And so I don't think you can kind of separate it completely.
I'm a little bit of a skeptic.
I know you are, Sarah. I know you are.
I think that there's a little bit of a difference between correlation of, like we know that findings in the gut are associated with certain diseases, but do we know that the strategies that you talked about change the gut in a way and then change those outcomes? I think a good example of that is like vitamin D supplementation. We know low vitamin D is correlated with fractures, but we haven't found that supplementing vitamin D then prevents fractures. And so can you talk a little bit about, I think, that gap of maybe like, are there studies showing that these strategies actually are impacting the outcomes that we know, or like, or does that not really exist yet? I don't know the answer.
Yeah, I think there is a subset of research that is looking at the specific intervention and at a microscopic level, seeing how that interacts with those disease pathways. I think it's really hard, again, like Wendy was saying, to kind of isolate the specific example. But at the same time, I think, again, if I zoom out of like our Western kind of methodology lens, and kind of understand like the development of like medical schools and how it kind of erased the like practices of like indigenous cultures that have been longer standing. I think you have kind of two competing ideologies, and I'm also a skeptic in the sense that like how research is conducted and the quality of it and who it includes and such. So on one hand, yes, I'm also like eagerly awaiting kind of very specific guidelines or like processes from research, but at the same time, I think just that method itself prohibits like understanding an organism as a whole, and honoring like kind of a synergistic effect. And honestly, there's so much that we don't know that I don't want to pretend to know, but yeah, I think there's just so much that we don't know, and I don't know how soon we're going to get those studies, again, based on other factors like funding.
Thanks so much. Great discussion. I'm going to wrap us up and then we'll
Okay.
transition to division meeting, but really a fabulous topic that gives us opportunity to discuss at so many different levels. So thank you.